A very good afternoon to all of you. Actually, there is one change for today. Uh, Doyle ma'am will be taking the class from 3:10 and I am taking the class from 1:10 to 3. Okay, in between you will be getting 10 minutes of break as per the schedule. So we can start by 1:10. Okay, please wait for 2 minutes. I hope the slides are visible and the sound is clear, right? Okay. So good afternoon to all my dear students. So we will be starting the session. Actually, I told you a few minutes before that due to some inconvenience, Doyle ma'am will be taking the class from 3:10 to 4 and I will be taking the class from 1:10 to 3. Meanwhile, you will be getting a break from 2 to 2:10. Okay. Yes, thank you for your feedback that the sound is clear and the screen is visible. Thank you. So this is the last class probably for the combinational logic circuit, and from the next week onwards you might be getting some new schedule. So we will be having the sequential circuit from the next week onwards. Okay, so today in the class we are going to discuss about some of the special ICs. Today the class is a bit that is the ICs are new and you need to learn a bit different thing. So I will request you to understand this one step by step, and I need your concentration a bit for today's class. Now many of you are feeling like that we have not given you the platform, that is many of you are saying that proteus is not available. If you are not having the proteus, the second option you have the circuit verse. The circuit verse you can use. Okay, and the third one I would like to thank Shobhik, and he is from section age, I think. So he suggested me that all of you are having some mobile phone, right, Android phone, so you can use some application there and it will be handy for you, so that you can use that one easily. So in the last of the talk I will be telling you the application that you can use. Okay, if you are not having the laptop, so if you are not able to do the proteus and circuit verse, you can do the that app also to do the logic circuit. Okay, So let's start with the, okay, sorry Shobik, you are from section J. Sorry for that. Okay, let's start with the topic. Now we will be dealing with the special 3 ICs. Please note it down that IC, even if you are not having the, in the circuit verse you do not have the number of IC, like IC number is not available, but in the theoretical part in Viva at least I will be asking you the question, that is which IC is going to do which type of thing, that you have to understand. Okay, so for this case we will be having this special IC 4539. This is the multiplexer IC, and using the multiplexer IC you will be doing the full adder and all these things. Okay, full adder, full subtractor implementation using the IC 4539B. Okay, and IC 4008, if you remember the COA class, many of you are losing your interest that what is the application of this multiplexer and adder and all these things that we are doing in the digital. See one thing, all these things, that is the adder, multiplexer, we will be using when we will be studying this week onwards the ALU design. Okay, ALU is the arithmetic and logic unit, and within the arithmetic unit you know that different types of arithmetic operations, like you have the addition, subtraction, increment, decrement. So how will you do that one within the COA? So you require the digital components like a multiplexer or a adder. So that is the application of multiplexer and adder, and you can use those things to implement the arithmetic and logic unit. Am I clear to you? That is, the COA subject is, you can say, the units of digital that you are studying, decoder, multiplexer, priority encoder, or whatever the things you are studying. This will be required when you are designing some ALU type of circuit. Okay, so that are the implications or applications of digital in the COA. Right, so you can say COA is the mother, and the main component of that is nothing but the digital. Now IC 4008, in the last class I was telling you RCA, that is the RCA was the ripple carry adder. So you can note it down that IC 4008 will be the ripple carry adder, 4-bit full adder. You can say there will be 4 full adders that will be existing in the IC 4008, and IC 4511, actually it is the BCD to 7 segment decoder. Okay, so we will be doing the practical out of this 3 things. Okay, so we will be learning mainly the 3 things. So let's come with the experiment number 1. So your experiment is like that, you have to implement a full adder, okay, using the multiplex. It is a complicated one. You do not know, you know what is full adder, but you do not know this multiplexer. So you have to understand how this multiplexer IC is going to work, and secondly you have to understand how any function can be implemented in the form of multiplexer. Okay, so this is the thing. So these are the applications of multiplexer: data selection or routing. Data selection means, if in the ALU, if you have, suppose you want to do 4 things: addition, subtraction, and then you have increment, decrement. So which operation is going to be at the output, because at the same time you are not doing all the operations, right? For some time you will be doing the addition of 2 number AB, for some time you will be doing the subtraction of 2 numbers, like that. So the data, that is, sometime you will be routing the A minus B or A plus B or incremented value D. So you require some channelization, or the data selector one, that is the multiplexer. So one point I have just noted here is the logic function generation. How can you use this multiplexer in the logic function generation? That is, you can say the full adder, if you think of the full adder having 2 output function, one is the sum, the second one is the carry. Okay, so when you are doing this one, you will be requiring the sum and the carry portion. So for that you are actually using this marks, and how you are using, for some logic sum you will be having one circuit, for logic carry you will be having another circuit. Okay, so this is the way I have just pointed out, because I will be concentrating on this point only. I'm not concentrating on data selection and routing. Data selection routing we will be telling you when we will be using this multiplexer in the ALU design. I will be discussing that how the data selection is going to happen using the multiplexer in the ALU design. This week only I will be telling you, okay, using the circuit diagram in the COA theory class. Now, in this case we can find out here, like if you want to implement any boolean function using multiplexer. So those who are joining recently, I like to tell you that we are going to cover 3 special ICs and related to 3 or 4 experiments. Okay, and first one is the implementation of full adder using the IC 4539B. Okay, now how will you represent a function using multiplexer? It's a general example I have given, so it will be easier for you to understand what is going to happen when you are using this in terms of full adder implementation. So suppose the function is f a b c. This is the function, okay? It's a function of a, b and c. So how many 3 variable means maximum value it can be 7 and the minimum value it can be 0, right? So when you are writing a function f a b c, that is it is in terms of min term you are representing the function. Okay, how you are representing the function in terms of min term. Okay, so what can I say from this expression? I can say that this is a function of 3 variable. Not more than that I can say. Okay, so let's see how we are representing this one. So when we are actually discussing about this thing, I can say that this function is actually represented by a implementation table. Okay, you can see here one term I have written here is the implementation table. Okay, so implementation table is what? You have to draw the implementation table when you are implementing a function. So when you are implementing a function, how you are implementing this one? You have to write in this fashion. That is, you are using a 4:1 marks, right? So how many inputs the 4:1 marks will be having? Definitely there will be 4 inputs. What are the 4 inputs? D0, D1, D2 and D3. Okay, so there will be 4 inputs of the 4:1 marks. Okay, now how we are writing this one? We will be writing this one as a bar a, and we are writing 0, 1. To forget about the red ones, why we are putting the reds, I will be, do not consider last row and the red values. Okay, you will be writing as 0, 1, 2, 3, 4, 5, 6, 7 like that. Okay, so when you are writing this one, you have to encircle the values which are given in the function. Okay, like the function is having 1, that's why I have pointed out this one as red. Okay, this function is having 3, that's why I have pointed out in red. You can encircle it. You have 5, that's why I have pointed this one as 5, and this one as 6, so I am pointed this one as red value in the D2. Okay, now from where you can say, ma'am, from where you are writing these values? If see, you just note it down this point, if no values are encircled, then it will be 0. If both the values are encircled, it is 1. If the lower value is encircled, that is lower value means what is the value? What is the row content? A, that's why I have written A. And for this, which one is encircled? The upper value. The upper is representing which one? A bar, right? So that's why I have written this one as A bar. Shall I have to repeat this one? Shall I have to repeat this one? Okay. So you have understood, I hope. So this is the function you are going to represent this one using the, okay, I'm repeating. Okay, wait. So what I am doing, I'm just telling you, if a function is given, the function is represented by what is the 3 variable, means what is the minimum value of the 3 variable, you can say that is 0 to 7, that is total 8 ta thakbe, tai to ABC means how many combinations, so 8 combination. So if I just remove this for sake, just I'm telling you, I'm just erasing all these things, okay. So when you are going to, suppose I want to write this one in this way, so when I will be writing this one, what are the 4 inputs of this? This will be D0, D1, D2 and D3. Suppose these are the 4 inputs, okay, of the multiplexer. So I will be writing the 4 inputs as D0, D1, D2 and D3. And here this A variable I will be writing here as bar of this, the MSB and the normal value. Now I hope it is clear to you. So we are writing this one, the implementation table format is that it is not truth table, it is the implementation table. So you will be writing as 0, 1, 2, 3 and you will be writing here 4, 5, 6, 7. It is not truth table, so you should not write 2 here and 3 here. Okay, so what is the next step? You have to encircle the values which are given in the function. So what are the value? 1 is the value, I will be encircling this one. The value is 3, I will be encircling this one. The value is 5, I will be encircling this one. And the value is 7, okay, sorry 6. So I will be encircling which one? This one, okay. Now what is the rule? If both the things are encircled, then it will be 1. If none of the thing are encircled, it will be 0. Otherwise, which row the encirclement is present, I will write that variable itself. Okay, so if for this column wise you will be checking. So for 0 it is not encircled and 4 it is not, so both are not encircled, okay. That's why we will be writing here as 0. For this both are encircled, that's why we will be writing here as 1. For this one which is encircled, this is 6, right? So 6 means which row? A. So I will be writing here A. And for this case, which is encircled? 3 is encircled, so I will be writing here A dash for this column. I hope it is clear to you. Ar bolte hobe? Nala arekbar bolchi. Please tell me whether you require another explanation. One more time I will be explaining. So when you are having, suppose if you have, just for example I am telling you, suppose if you have a function like ABC, okay, ABC, and it is, suppose you have 1, 2, 3 and 4. Can you tell me how can we do it? So I will be doing it here also. There is 3 things, so you can say using the 4:1 marks we will be doing. So we will be writing D0, D1, I mean ekটু তাড়াতাড়ি বলছি, D2, D3, and you have this MSB as A bar and A, okay. And then what are the values you will be putting? 0, 1, 2, 3. It is not truth table, this is the implementation table, so it is 2 and 3. And then you have 4, 5, 6, 7. So what we are going to happen, encircle which values? 1, 2, 3 and 4. So encircle it 1, 2, 3 and 4. So can you tell me, suppose I am giving you in the Viva that question, that function is this, implement this one using the 4:1 marks. So you will be telling that, ma'am, it will be encircled means this is A, this is corresponding to this row, this is corresponding to the upper row means A bar, this is the upper row, that is A bar, and this is again the 3 is in the upper row, that is A bar. So what is the thing? You can say that the 4 values of the marks, just understand this point clearly. 4, এটা যদি না বুঝিস বাকিগুলো বুঝতে পারবি না. So the first variable what we are putting it for this example, the second example, what is the first variable? A. So what value we will be putting for the D01? A. বুঝেছিস? Second, D1, what is the value we are putting here? A bar. Okay, yes, A bar, third is A bar and fourth is A bar. Okay, now you tell me what are these two select line, because marks must be having two select line when it is 4:1 marks, right? So these remaining two variables, that is the B and C, will be working as the select lines for this implementation of mask. Okay, so if you have this, so this MSB A, okay, so this MSB A will be working as this. Okay, this MSB A will be working as the select line, sorry, the leftmost side, and this B and C will be working as the select line. I will be repeating this one if you require. Okay. You are having lots of queries. See, the last time I am repeating this one. Okay, suppose you have a function of ABC, you are representing this one in this form, mean term form, and if I ask you how will you implement this one using the 4:1 marks, the answer is like that. The 4 input of the mask will be D0, D1, D2 and D3, and then what we are doing, the MSB we are writing in the complement fashion, and the second row we are writing as it is. We are putting the values as the values like 0, 1, 2, 3, 4, 5, 6, 7. We are encircling the values within the mean term expression, that is 1, 3, 5, 5, 6, 1, 3, 5, 6. And when both the values are not encircled, then we are putting 0. Column wise we will be checking. Both the values are encircled, we will be putting 1. If some of the, that is out of 2, one value is encircled, the corresponding row value I must put as the result. Okay, here is a 6. That's why we are putting A here. Here for this column it is 3. That's why we are putting A bar here. Arya, it is clear to you, I hope. Okay, now here we are using the select lines of the mask as the next two variable B and C. Okay, because you need to represent the function, you may write for this and you can check what is the function of this, because when we are representing the thing, because A already has been used here, so the remaining two variable, the function needs to be represented out of the three variables, right? So if one variable is already here, so why should we use this variable for select line? The remaining two we can use for select line, right? Wasim, is it clear to you? The remaining values we can use. If you are representing like CBA, I can write it here as a function of CBA, then B and A will be working as a select line, the whatever will be the MSB, that we will be writing here. Okay, and the remaining thing, the whatever with it may be like B is like CAB. It can happen CAB, then C will be working as the that is the here C bar C, and then AB will be working as here select lines. Is it clear to you? So it depends on the way the function is given to you in the examination. Maybe it is a new concept. Maybe if you are finding any difficulty, I will be telling you once more, because here I cannot tell everything more than 3 or 4 times, right? So see, this is the thing. So this is the multiplexer. So for this case we have done, and we have obtained, I have not encircled but I have just pointed out with red colors, and I have just pointed out whichever is red, I have, that is for A, this one, and this is red, that is belongs to this row, that is A bar. Okay, now what will be the values of this? 0 means what? It is grounded, right? This is a ground symbol from the first year itself, you know this one. Now remaining thing will be what? The second value is what? This will be 1. 1 means 5 volt power. Okay, so power 5 volt will be there for the second. So what is this? This is basically the D0, this is the D1, this is D2, and this is basically D3, right? And what is the output function? This is basically the output function F. Okay, And what is these two values? These are the two select lines B and C. Right? It is clear to you? If this is B and C and this is the thing. So you can simply implement a function. So if I talk about a full adder, how many outputs the full adder will be having? Two outputs. For one sum, you have some min-term expression. For carry, you have another min-term expression. We can be using two multiplexer. One will be implementing the sum term and another will be implementing the carry term. Is it understandable? So we will be using this policy to implement this one. Now, let's see this one. So full adder thing, it is known to you. I am not explaining once more time. So this is the truth table of the full adder and application of full adder in the ALU part, and in the RCA, that is the ripple carry adder also. You will be using the multiple 4-bit RCA, means 4 full adders you will be using. This we have done already. Shondip, is it clear to you? Shondip? Okay. Fine. So let's have this one. So if you think about this, where are the ones? This is the for 3, for 4, 5. This is for the 6 and 7, right? So carry function, can I write it here? The carry value, the cout. So for some value, where are the ones? And for carry value, where are the ones? We can easily write these values as the summation of min terms of those values. Now check where the ones are existing. For some, this is 0, 0, 1 is 1. For this 2, sorry, this is 4 and this is 7. So 1, 2, 4 and I should write comma here, 7. So 1, 2, 4, 7 is for the sum. And for the carry, what are the values you will be having? This is 3, this is 5, this is 6 and this is 7. So I can write it here as 3, 5, 6 and 7. So suppose this is a one function, the sum is one function, right? So this function, can we use 1 4:1 marks to implement the sum part? And then for carry, you require another 4:1 marks for implementation of carry. Can we do that? Okay. So your question is, you need to implement this full adder using the marks. So you require how many minimum number of marks? 2 4:1 marks. One will implement the sum, because you have the min terms given here, and another for carry. So let's see how you are having. So these are the, you please note it down, 1 2 4 7 and 3 5 6 7 are the basically two min terms. Now let's check it. You can do it by yourself, okay? Plus please take your time and do it, because the theoretical portion, because it is not yet done in your class, so I need to, otherwise you will not understand how to connect this. So you do it. 1 for sum, the value I have told you in the previous, 1 2 4 7 from the truth table we obtained. So this is 1 means which value? This value, right? So 1 2 and this is 4 and this is 7, right? So for 1 2 4 7, which are the encircled values? It is shown to you. Can you tell me what will be the value of this 4? Just do it fast. So for this case, which is the encircled value? 4 is the encircled value, right? So what is the row corresponding? This is corresponding to row A. This is the upper one is corresponding to A bar. So I should write A bar here. Next, it is D2, it is corresponding to A bar. So I should be writing here A bar, and this is corresponding to A. Okay, so I will be writing here A. So for some implementation, BC I have already pasted it here. So I do not have any other option. So this two will be working as the two select lines. So sometimes we call it as S1 and S0. Yes, Shobik, you are correct. So what should we write? So this will be D0, this is D1, this is D2 and this is D3. So D0 is basically what? A, right? So D0 column is basically what? A. So I will be putting here as A. The D1 is A bar, the D2 is A bar, okay, and last D3 is A, right? So if you have three inputs of a summation A, B and C, these three values you will be giving and the sum value you will be getting at the output of the marks, okay. Now for the carry value, so this is the value we have done. The next slide I have pointed, the previous one I will be deleting when I will be posting it in your group, okay. So some part is done. Buchis na my ball. Okay, so if I have understood, then fine. So what about the carry part? The carry, within the carry part you have these values, right? So this 3, 5, 6, 7. So you encircle it. So 3 is where it is placed, 3, then it is 5, this is 6 and this is 7. Now for this case, what will be the value? None of the values are encircled, so it will become 0. Correct. Shukanna, you are correct. Okay, 0. What is the D1 value? It is the 5 is encircled and this is belonging to which row? A, right? So you should write here A. D2 is also in the A row, that you should write it here A. And for D3, what should be the value? Yes, Shondip, you are also correct. Shobik, you are also correct. Okay, so for this case, if both are encircled, what will be the value? It will be 1. Okay, now what should we write here? We will write here 0 because this is the D0, D1, D2 and D3, and it is 0, A and this is 1. That is, this 0 means you should know this is the ground, and we should write component is basically like this. We have done this one, and this 1 is basically the 5 volt. Generally in the ma'am, you showed A and A bar in the separate line input, but can we do this one by adding? Yes, definitely. So you are telling me that, I am just going to the previous slide. He was telling that can we do it? Yes, definitely we will be doing like that only. So if you have practically, when you are going, you will be doing this, and then you are shorting this one with the last row, okay, because both are shorted, both are A and A. So how you are going to get a A bar? You will be putting a knot out of this, and you will be connecting this one to this, and you are connecting this one to, that is D0 and D3 are going to be A, and this D1 and D2 you will be putting one NOT gate passing through the A through this. You will be getting the A bar, and you will be passing this one to the D1 and D2. Correct? You are correct. That is the rule we will be using. This is the way we used to do it in the implementation table. Okay. Okay. Now come to the practical point of view. So you have the circuit diagram of this A and B. Okay. And here we can find out that this is the IC diagram of the 4539B. Okay, so if you have some IC in the hardware lab, you might have obtained this to access this type of ICs. Those are available in the lab, but unfortunately due to the lockdown, we are not doing all these things in the hardware lab. So you can do it if the college reopens. If it is possible to reopen, then you might have the chance to at least do 1 or 2 experiments. Anyways, so this is the pin diagram, and you can see here that this is the to enable. Enable is basically the two select values, if the enable is basically 0 here, then the marks is going to be enabled. How many multiplexers are there? In this side one multiplexer, in this side another multiplexer will be there. Okay, and how the select line values will be selected? You can see the pin number 2 and pin number 14. Pin number 14 is basically the S0 and S1. So pin number 2 is the highest priority. If you see the select line, S1, S0 we should write in this order, right? We do not write S0, S1. We should read from the left hand side. So S1, S0, so pin number 2 is having the higher priority than the pin number 14. So pin number 2 and 14 will be working as the select lines for both the multiplexers. Okay, again it got hanged. So anyways, so how the multiplexer 1 is going to work, you can check it, that just wait for 1 minute. Okay, so how this is going to work, you can see here, just understand the thing. So the two multiplexers can work together depending on the values of the select lines. Okay, then select lines will be common to both the marks, because definitely when we are using the marks for sum and carry, for definitely ABC value we are calculating the sum and carry both, right? So both multiplexer should be working when we are using the select line. So for both the cases the select lines will be S1 and S0, that will be connected to both the multiplexers. So for the marks 1, maybe you will be implementing the sum part from this point of view, that is 3, 4, 5 and 6, that is 0 means D0 is I0 here, D1 is I1 here, D2 is I2 here, and D3 is I3 here. So this order, so 6, 5, 4, 3, this will be the order, and output of the first marks you will be getting from that OA, and this is the ground, and this 16 pin is basically the VCC, 5 volt you will be giving. And enable value you have to give. For this practical point of view, in the Proteus we will be using another thing that is known as strobe, STB you will be learning. Okay, so within this IC how the things are there, this is one multiplexer in the multiple choice question itself. Just wait for 1 minute, I am keeping the attendance link because last day it was not opened. Okay, okay, so for this case actually what I was showing, that for multiplexer 1 means this part, right? So this is the part, so that is 3, 4, 5, 6 are the input values, and you can see here the two select lines are basically connected to both the multiplexers. So if it is 0, 0, S1, S0, we should read the reverse way, the S1 first then S0. Okay, so then for both the multiplexer, whatever is in the 0, I0 will come here, and here I0A will come at the output and I0B will come at the output. Okay, if it is S0 is equal to 1, S1 equal to 0, that is 0, 1, 0, 1, then I1 will come here, and definitely I1 for this will come here. Okay, a bit difficult concept, but it will be habituated, that is you people will get habituated with this one if you give some time, because I am doing fast because I have to cover the syllabus, and if I do not get time to do all these things for all the sections, then it will be difficult for you. Okay, so these are the input of the 2 marks, and these are the select line, these are enable pin and all these things. Okay, maybe for this case, please remember, for this case the enable hardware circuit, the enable will be active low because the IC is specified like this, it depends on the manufacturer. But for this Proteus part, the strobe is acting as the enable and it will be high. Okay, now in practically you will be seeing that you can purchase this one from the different Amazon, or we used to go to Chandni to purchase all these things, and you will be frequently dealing with the term DIP, that is dual inline package. So how the multiplexers or whatever is the IC that are packaged, that is because lots of transistors are existing within this, so the packaging is important. So DIP term is the dual inline package, and how many pins are there, you can say here 1 to 16. So there are 16 pins that are existing. So dual inline packaging including the 16 pins, and the technology, it's not TTL, right, it's a CMOS, because all the 4000 series IC are basically the TTL IC, right? So TTL IC are there, but the 74 series IC, but we are using this 4000 IC series IC, so it is basically the CMOS ICs. Okay, now, so what is the look in the Proteus platform, that you have to understand. Now in the Proteus, if you think of this one, you can just check this one. The strobe is working as basically the enable pin. Okay, so I can just write it down here. The strobe is working as the enable pin here. Okay, so for strobe 1 and strobe 2 means strobe 1 is for this multiplexer part, and for strobe 2 this is the 4 input of the second multiplexer. Okay, so when you are thinking about the strobe 1, so as if x0 this is the value, so x0 x1 x2 x3 is basically doing the max 1 input, and this is the max 1 output. Okay, so you can implement, you can do the connections like the sum, what you obtained for the sum, you did the first A and A you did here, and A bar and A bar you did here. So you are getting the sum, you configure the A value first and last, and the two middle values to the A bar, so you will be getting the sum output from this section. I will be showing you. And the second carry part, you can just do it for this the second marks inputs are there, that is y0 y1 y2 y3, and you will be getting the output of marks 2 from the pin number 9. Is it clear to you? So what are the select line here? What I told here, what will be the select line for this? Actually this select line, if you do not want to write here, for sake of if you want some similarity between the hardware and this part, you can say here these two are as if the enable values. So enable value in this case it needs to be 1, otherwise the marks, if the strobe 1 STB1 is 1, then the marks 1 will work. If STB2 is 1, then the marks 2 will work. Otherwise, the marks 1 and 2 will not work. So this is the primary condition. The strobe or STB must be 1, so the marks 1 will work. This is a primary condition. Similarly, STB 2 also will be 1, that is a STB2 will be 1, then the marks 2 will work. Okay, that's why we have put this one 1. And what is this two values? You just check it, and which one is S1? 2, right? S1 is basically which one here? 2 means this is S1, and what is A? This the 14 pin is connected, so this is basically S0. Okay, so you have the parity between the Proteus platform and the real-time IC platform. This is the okay, so any question up to this? Do you have any question till now? If you have any question or any bit of recapitulation is necessary, then you just tell me, ma'am, this is the problem, please explain. Maybe we may not get some time further. Okay, so anyways, hopefully you have understood. So this is the platform we can implement the marks value STB portion. Okay, strobe, here you can say if the enable is 1, okay, then it is going to or 0, it is active low signal EA bar. But in the practically when you are using the Proteus platform, the strobe point needs to be 1. So to enable means the marks 1 will not work at all. Whatever the values you will be giving, it will not select that one at the output until and unless you are making the strobe as 1. Just see the example. For this case, I am just using one simple example here as this value as strobe out of 2 marks. How you can, from the picture, what you understand, that I have used how many multiplexers? Can you tell me? 6, 5, 4, 3. So this is, I have used only one multiplexer out of the 2 multiplexer. I have not connected 10, 11, 12, 13 or neither the output of that. Okay. So what I did, yes, one multiplexer only I have connected. And what I did, I have not connected 1 to strobe 2 because I am not using the second multiplexer, right? So I am only the first multiplexer. That's why what I did, I used always 1 at strobe 1. If you put 0, you can check for your experimental purpose, this multiplexer into whatever the select line values you will be giving, it will not reflect it. Now what is the thing? Select line is what? S1 and S0, right? These are 2 select lines. So what are the values? I will be, this is basically what? Which one is S1? In the last slide, what you did? S0 and S1. So 14 is basically, this is S0, right? So for 14, this is basically S0, and for sake of your simplicity, I am writing here for this one is S1. So both we should write S1, S0 as, this is, just wait 1 second. This we are writing as 0, 0. So when these 2 values are 0, 0, okay, then out of which is going to be at the output? Can you tell me? If the select, you know the select line combination, what is going to be the output of marks 1? Definitely D0. If it is 0, 1, what is going to be the output of marks 2? D2, sorry, D1. If it is 1, 0, what is going to be the D2? If it is 1, 1, what is going to be the D3? Here what is D0, what is D1, what is D2? So this is basically here for this case, this is D0, it is D1, it is D2 and it is D3. Got it? So that's why if it is 0, 0, whatever is D0, that is X01, that's why we are getting here 1. বুঝতে পেরেছিস না পারিসনি? So strobe is always 1 because if it is not, this marks will not work. That is the first point I told. Secondly, this is working as S0 and this is working as S1. So if it is 0, 0, we should write, or we should read from this side 0, 0. This one X0 is coming to the output. Let's see the next example. Okay, I should just, so in this picture it is written already here, the strobe 1 is to be 1. Okay, then the marks will work. The select lines are basically pin number 2 and 14 AB. Okay, and when this pin number 2 and pin number 14 0, 0, that is the 2 select lines are 0, 0, then what you are getting? The X0, that is pin number 6 input of the marks, that is this value is going to where? Pin number 7, that is here. Got it? So similarly you can do it, you can try for your practice. For this one, the strobe 1, I have kept it intact. The second value I have taken, this is 0, 1, that is I should read from this side to this side. This is S1 and this is S0, right? So it is 0, 1, then the next value is coming to the output, that I have written here. You can check it. If it is 0, 1, S1, 0 and S0, 1, the second input X1 is coming at the output. Okay, the second case. Third case, I kept it 1, 0, then the third input is coming at the output. If you go for the fourth case, 1, 1, the fourth input is coming at the output. Okay, is it clear to you up to this? Up to this, is it clear? Shondip, is it clear to you? You can implement, those who are having proteus, they can implement this one. Okay, Now you can use this one. I am just opening the. So the first one I did it for this one. Okay, just wait for 1 minute. The simple 4539B IC. I hope today you found some difficulty because the concept is new. But if you practice, it will be, if you study 1 or 2 times, you will able to understand this one. I think you people are intelligent enough, because the people who study less and at the end of the exam they score more, I think they are intelligent than me also. Okay, just check it once again what I told there, that depending, I just do the start SVM and you can do the run simulation. Okay, so you can check here if you are using 0 0 here, the first one I should read from this end. So you are using 0 0, but you have given the input 1 or 0, you are changing. Is there any reflection at the output? I hope there is no reflection at the output, right? Because only the x0 value is going to be here. So if it is 0 0, whatever is the x0 value, that is coming here, because it is working at the first marks. Okay, if you are going for this one 0 1, definitely whatever is here, it is not going to change, but whatever is the second input, if it is 1, then the output is 1, if it is 0, then the output is 0. Okay, now if you go for the second one, okay, that is 1 0 is the third one. So the third value, it is 0, then the output is 0, third input is 0, then the output is 0. If you make it 1, then the output is going to be 1. Okay, and if you think of the fourth one, that is both the select lines, S1 is 1 and S0 I am keeping 1, then what you are obtaining? You will be obtaining whatever the changes you may do, that is not going to change the output, right? Only in which case it is going to change? The fourth input. Okay, if the fourth input, because the select line is 1 1, means x3, that is a d3, what we told in the theory, is going to be, if it is 1, then output is 1. Now for your understanding, if I tell that you make the strobe equal to 0 and you make 1 1, whatever the select line value is, I am making a special case, the last special case I am telling. Suppose you are making the strobe equal to 0, STB equal to 0. So will it work? Will the first marks work? Let's see. Suppose it is 1 1, then whatever is the input, that is supposed to be at the output, right? But is it working? No, it's not working, because the strobe you have kept it, I have kept it in the 0. You make it 1, then you change it, it will be working. Okay. So this is the thing. Yes, it will not work. So I hope you can do it by yourself, right? Okay, just take 5 minutes of break and I will be coming to the session. Okay, back. Now how can we construct the full adder? I will be telling you. Just take 2-3 minutes of break. Do not go for a long break, or you can just, who are willing to just do it by yourself, they can just do it. The marks 1, how you will connect it to implement the sum part, marks 2, how you will connect it, and what are the values of the strobe 1 2, it should be 1 1, and you can do it. Okay, I will be coming back by 2 6. Okay. Okay, are you there? Um, can we start? Okay, so we were discussing about the yes, okay, so we were discussing about how we can construct the full adder using this, and let's talk about this one. So see, in case of full adder, what we did, that the marks 1 we obtained, for the marks 1 what we thought of, that marks 1 will be doing the sum part, and marks 2 will be doing the carry part. Okay, now for the marks 1, what was the circuit configuration? I am just telling it in short, just for sake of your remembrance. Okay, so what was the circuit diagram? You just tell me. It was A, then it was A bar, and A, right? It was the thing. Okay, and the second one was actually the BC, that was working as the select line. So we did the B and C, and we got the sum value. That is the 4:1 marks we used to implement. So can we implement that one? So we can think of the A is one value, and that value will be coming to the first value and the last value. Okay, and we can think of that there will be one NOT gate you can use, and you just short this two by connecting the wire, and you just place it to the middle of it. Okay. So what I did, A is connected to the pin number 6 and 3, that is first and last, and we used a simple NOT gate that Shobik was telling, and you just short this 4 and 5 and you connect it like this. So what is the output you are supposed to get from the pin number 7 is the sum output. Okay, similarly, how to do the carry output? If you remember, the handwriting is not good, I really sorry for that. So this is the 4:1, and for the carry out, what you did, that if you remember, the first one was 0, second one was 1, and this 2 was actually A and A, right? So you can short this 2 and put one A here. So what we can do, actually we can put some 0, or we can ground it. I will show you how to ground. And so you can give 0 as a separate input. You can just click the in the logic the logic value 0, and here 1, and you can short this to that, and you can put this one what is coming here to x3, that you can extend and put it here. Okay, so this is the way you can connect it. Now what are these values? So I should not write here A and B, rather that I should write here the select lines. So what are the select lines? What should be the way, which is the higher order? Which one is having the higher order? Can you tell me? 2 is having some higher order, right? So 2 will be actually S1 and this is S0. So if you have the variable A, B, C, out of B, C, which is having the higher order? This B, then C, right? So this will be working as B and this will be working as C. So basically B, C, you are putting the input from here, and C value you are giving from here. So A, so you should read from here, when you are giving input you should read A, then B, then C. This is the way actually you are giving the 3 inputs of the thing. Okay, and what are the values of strobe 1 and strobe 2? It should be connected to 1 and 1, because until and unless it is you are putting these 2 values as 1, you will not get. So if you are giving these values 0, A and 1, you will be getting the carry out from pin number 9. Okay, so this is the way. I am repeating once again. I have kept this A here. This marks is working as the sum, the corresponding output sum you will be getting from pin number 7, and the second marks is working as the carry. or it is going to generate the carry. So the pin this marks what is the value. You did it in the last slide, if you remember the slide from where I am writing these values actually. Okay, so anyways, you have the documentation hopefully. So you can have this a bar, a, right? So what I did, a, that is coming to the first and the last, because the first and last both are a, and this two middle two row I shorted it, and a bar we use a NOT gate. Okay, and for the carry part, what we did, the first is 0, the second is 1, the way we did 0 and 1, the middle two will be a and a. Okay, so I shorted it, and that value of a you connect it here. Now what I told this is you should not think about a, b, because a you have used. This is for sake of their IC recognition. This is basically S1 and S0 we did it, and for this two line it is the S1 and S0, right? So which is having the highest priority, definitely the higher value is S1. So B is having, so in the place of S1 I will be writing B, and in the place of S0 we will be writing the C. So B and C will be, so when you are giving the input, because you have to make the truth table of A, B, C, then sum and carry, right? So how you are reading, you will be, suppose when you are giving A 0, B 0, C 0, how you are going to, here you have to give 0, B for here you have to give 0, and here you have to give 0. You will be checking the sum is 0, 0, is it coming or not, that you have to verify. Bujechish? Otherwise I have to tell once. Okay, now so this is the circuit diagram I have. I'm just going to the circuit diagram which is effective. So I will be showing you the full adder circuit which I have described in the slide in the proteus. Okay. Okay, so what I did here, the strobe two values, just listen carefully, the two then you can implement by yourself. The two strobe values I have kept as 1 1, fine. The why the second marks first input was 0 and the second input was A, right? Second and third, and the last input was A, right? So this one y0 and y3, if you remember the slide, the way okay, I have discarded the, anyways, so I can debug this one. Now you can check it here by yourself. The two strobe values are 1 1 because we want this marks that is going to do the sum output, and the second marks which is going to give you the carry output. Both the things should be active, right? So these two values are 1 1, fine. Which is the value A? This one is A, this one is B, this one is C. So we should write it here, A, B and C. So if it is 0 0 0 means 0 0 0. Okay, 0 A 0, B 0, C 0. C 0 means the LSB is 0. So if the LSB is 1, what you are supposed to get, sum is 1 and carry is 0. Have you understood this point? So if I am going to write about this, so can we write in the truth table that if you are giving A 0 0 0, then what you are supposed to get here? What you are supposed to get here? You will be getting sum equal to 0 and carry equal to 0. How you are getting here? By putting, suppose 3 values are 0 0 0, so sum 0 carry 0 you are getting. Now if you are giving A0 B0 C1, yes, you can join two STB and put 1. That also you can do it. You can short the two things and you can make it 1. Okay, which portion shall I repeat? Vicky, can you tell me which portion can we repeat? The strobe value, somebody Banerjee is telling that you just short this 2 and put it 1. Yes, you can do that as per your convenience. There is no, please check it whether the output is coming. Now second option is A0 B0 C1. That is which option? This is A0 B0 C1. What you are getting? You are getting sum 1 carry 0. So you are supposed to get that one also, sum 1 and carry 0, right? That you are getting. Now the second thing is done. Third thing, A0 B1 C0, that is 0 1 0 0 1 0. So it will be again sum 1 carry 0. It is fine, it is correct. So this is the way you can just complete the truth table. For some of the cases I am telling you. So 0 1 1 for 3, okay, 0 1 1, A0 B1 C1 3. That will be 2 1 means this is the circuit for full adder circuit, which I have shown you in the slide. That circuit I am explaining. This first circuit is working for the sum generation, that is this mass, and the second circuit is the second inputs are going to give you the carry generation. Okay, this first one is the sum value, this is the carry value. This is the A, because for adder you need to give 3 inputs. A is this, B is this, and C is this, because these two are basically the select lines. Instead of this, writing this, I have shown you in the slide that you should write this is as a select line 1 or 0, or you can say this is as B and C as per the okay. That was okay. I got your question. That was the single circuit. How the one of the two multiplexer is going to work, that I have shown you in that previous circuit. You are talking about this circuit, right? How the marks is working depending on the strobe and select line, that I have told you. That is a simple IC specification. I have not implemented anything. The simple one of the marks how it is working. But this, the second experiment, actually this is the experiment. Okay, that is you need to implement the two functions of full adder. One is sum, another is carry. That I have shown you how to implement the functions. So the first one we have implemented the sum, second one we implemented the carry, and these the input. This A, B, C are the 3 inputs you have to give, and you have to keep the 2 values. So you can complete the truth table. The last one I am telling 1 1 1. If you give 1 1 1, you should be getting sum 1 and carry 1. Let's check that one. If you are giving 1 1 1, that A, B, C as 3 ones, you will be getting sum 1. This is a sum 1 and carry 1. So the up to last it is working, right? So this is the way you must put the observation. Shoham, is it clear to you? Okay. Now this is the thing. Now the second circuit is that you have to implement similarly the full subtractor. If you have understood the full adder, you can do it. The full subtractor part also you can easily do, right? How you can do it? Just please tell me the truth table and all these things. You have to write down the truth table for the full subtractor. What is the normal approach? The approach will be that you should draw the truth table of the full subtractor first. You should write the second thing, you have to just write the d value sum of some mean terms and b out as sum of the mean terms. Okay, so what can be the values of this? You can just see for d it is 1, 2 and then 4 and 7. Okay, so I have done this one. For the difference d, the function of a b, instead of c we are writing as b in the previous borrow, and 1 2 4 7 the same way we did. Okay, the same way we did for the full adder, we can do it for this full subtractor. You just write down the points. What you have to do, you just write the truth table of the full subtractor, then that is the first point. Second point, you have to write down the expression of difference in terms of the mean term, summation of mean term 1 2 4 7 for d, and for borrow it will be 1 2 3 and 7, right? So you can check it, 1 2 3 and 7, that will give you the mean term function for the borrow. That I have just written here, 1 2 4 7 for difference and 1 2 3 7. Just do it yourself, and can you tell me that what will be the this value? So because we have to just implement the first marks of 4 5 3 9 using this implementation platform, and the second marks for this for the second case. Okay, now if you think about this, you can just do it by yourself. What are the values? Can you just do it by tell me what can be the values for this? Solve this one. For difference part you need to do the implementation table. Yes, this is 1 2 4 7 means the same value as sum which we used. Okay, 1 2 then 4 7, so that was the same thing we obtained in the sum. So it is a, then it is a bar and a, right? So same thing. Yes, yes, it is correct. So definitely you should give the 4 inputs accordingly to the multiplexer. So you are going to get, Shoham, please wait for 1 minute, let me do it, then I will be clarifying your. Okay, so you will be getting the difference part from here. Okay, or the way you did it, you can short this too and you can put a NOT gate with a to do it. Okay, now the second part is borrow. When you are doing the second part, so what is the difference? It is a different equation. Definitely 1 2 3 and 7, so it will be 1 then 2 then 3 and then 7. So what is going to be the outcome? It is none of these two things are encircled. If two things are not encircled, then it is going to be 0. For this case it is going to be a bar, for this case it is going to be a bar, and for this case it is going to be encircled. For this two, Shukarna, you are correct, so it is going to be 1 if both the things are encircled. Okay, Sneha, you are also correct. Vicky, you are also correct. Why you are telling a bar a, it should be a bar. Vicky, please check, it should be a bar, it is not a, because 1 and 2 are residing in the first row, that is corresponding to a bar. So here you can just put the values here. 0 means it should, this point should be grounded, and then the second case it will be a bar, and the last is going to be 1. So this is the way you can just connect the 4 inputs to the second marks to get the borrow part. So please note it down. So the first case, because if I just discard the annotations, it will be erased. Okay, so the first case a bar a for difference, and for the second case it will be 0 a bar 1. Okay. So only a difference is that when we have multiplied or when we have implemented the thing, we can check here that for this case we have done A this side, same B and C the way you have done. You can short this two and you can connect one with this. So I have did separately strobe 1 equal to 1 and strobe 2 equal to 1, and for this case one change is there. You see from here it is A, right? So this is going to be A here. So this is working as basically A. This is basically A, this is B and this is C, right? So if it is like that only, then what is the thing you will be getting? So this is B and C. This is basically the first is grounded. So instead of giving 0, you can give the ground option here and you can give 1. This is basically power or 1. Okay, and what we did here, the two things we have shorted because it is A bar. So this is A. So this basically passed through NOT gate and you got A bar. So A bar is connected to the middle to Y1 and Y0 to get the borrow out. That is a final B out. Okay. Is it clear to you? I hope it is clear to you, right? Any doubt till now? If you have understood the full adder, you can do it for the rest part also. This is the second case. Some of the examples I have given. So for the first case is a 0 0 0. You got the difference 0. The first is basically the difference. The first one is showing you the difference, right? So when you are thinking of this is the difference and this is the borrow out. Okay, so both are 0 0 when A B. So when you have the A B C 0 0 0, then you have difference and borrow out as 0 0. So if it is 0 0 1, what it should come? You should come 1 1, right? So let's check for the second case of input. The second case is showing basically this is A B C. So this is A, then B and C. So it is giving you 0 0 1 and you are getting this. You can just check the theoretical truth table. You will be getting the difference D and you have the borrow out. So both are basically 1 1. That you will be getting. Okay. So like that you can just do it by yourself, and if you am just skipping this one, for rest of the combination we can show it in the simulator itself. Just wait for 1 minute. So this is the thing. We have used one extra NOT gate here. Now how to get this value actually? Suppose I am just telling you one thing. You can do it. I think you can do it. So whatever the thing when you are putting some separate value, like it may be 1 1 0. So 1 1 0, you will be getting whatever the value you will be 1 1 0. You will be getting the values like that. Okay. Now so even you can check any values, 1 1 1 you can check here, or 1 1 0, whatever the values you will be getting. Okay, 1 1 1, the difference 1 and borrow 1. So any values you can put here and you can do it. Now how to get this either you can put, I can also put this one as this power. How to do this one? Actually you can just right click and you can use some place. Okay, I am showing here how to get the symbols like this. You can write and you can just put place and you can just go to the terminal and you can just put a ground or power, these two values. Okay, If you have ground, then you will be getting a thing like this. I should skip the stop SVM, then I can just do it. So right click any of the places, right click any of the place, then go to terminal, then go to the ground. So if you put, you can just, the ground symbol, you can just put it here. Okay, similarly if you want to get some power value 5 volt or something like that, you can just connect it here, terminal, and then you have the power value. So power value will be coming like this way, the reverse order. So what you can do it, you just place it and you just right click and you can rotate clockwise, and then again right click and you can just rotate clockwise. Okay, so you can just connect to anything like that. So you can connect it here with that one also. Okay, like if I do not connected this one to this, so you can connect this to this also. Okay, so this is the way you can just do the subtractor part. Okay, now 2-3 things, some of the things are there, observation table. I'm just skipping all these things. I'm just coming to the next part that is very important, that is familiarization with the another IC, that is IC 4008. So when you are discussing about the 4008, it is the 4-bit full adder circuit. So when you have the 4-bit full adder circuit, 4-bit full adder means what? There will be two numbers A and B. Suppose you have one number, A. So when you are going to add the number with B, both are having the 4 bits. Okay, so what can I say, that A is a number consists of like 4 bits, A3, A2, A1, A0, and B is another number consisting of B3, B2, B1 and B0. Then you will be adding those two numbers to get the sum. So when you are getting the sum, what you are getting here, that A0, B0 will give you S0, S1, S2, S3 and some C out. Okay, this is the way. Actually the RCA, that is the ripple carry adder, we did is basically this IC 4008. That is the practical implementation of that. Now how to implement this one, we will be observing one by one. Four five three nine. 45, it's not 8539, it's a 4539. Okay, okay, drawing size zone you can increase by maximizing. You can see a plus sign there. Okay, you can just see a plus sign. Just wait for, I will be telling you the question. Lots of queries you have. You want to maximize, you have the plus sign here, you can zoom in, so you can just do it, or if you want to drag it, you can do it by dragging the green color button. Okay, Arya, is it clear to you? Y3, where is Y3? Just wait. Y3 is connected to 1. Y3, Vicky, Y3 is connected to 1. Why it is connected to 1? Because I told you, for the multiplexer, when you are going for the borrow out, you did 0, A bar 1, right? So this is the 1 that is connected. And how you are getting this 1 and 0, I told you, right click, you place the you click the terminal, then you have the power. This power, if you click, this will, you will get, and if you just do the clockwise and you select it again, you do the clockwise, you will be getting the this way. Okay, this is the way y3 is connected. Anything which is positive or 1 means this power sign. Okay, you can connect I can connect this one type here also, because 1, or you may short this with all these things, the way the Bandyopadhyay was telling that you can short it also, but you are doing initially, that's why I am explaining like this. Anyways, I hope it is clear to you, right? So anyways, so what I was telling, that A3 B3 A2 B2, all these things are basically the bits of the number that you are going to add. Okay, so when you are having the two numbers A and B, all the numbers A are having 4 bits, B is also having 4 bits, so the sum that you will be having 4 bits along with the C out. Okay, so how you obtain this one, just go to the next slide. This one you did it. So A is suppose a number, suppose A is a number, and A is going to be suppose 0 1 0 0, and B is going to be like 0 1 0 0. So what are the values? This is the, you can say the A0 A1 A0 A1 A2 A3, these are the bits. Okay, and similarly B0 B1 B2 B3, these are the 4 bits of number B, and these are the 4 bits of number A. So definitely you will be adding column wise, and you will be getting the sum 0, sum 1, sum 2, and sum 3 along with the C out. So this is finally, so maybe this is, if you just write it A1 to A4, that also you can do whatever. So if you just get the internal structure of this, you will be getting this in the class I told you. So within each, this is having one full adder circuit within this and this. Okay, so but we are actually representing all these things within a simple IC diagram. So I told you in the theory, if you have a number A having 4 bits, B is a number having 4 bits, you will be adding these two numbers to get the output 4 bits along with the final carry. Okay, so any 4 numbers you can take. I have added 4 with 4, you got 8, right? 0 1 0 0 is 4, 0 1 0 0 is 4, you got 1 0 0 0 is 8. Okay, so you can add 8 with 8, you will be getting 16. So like this, because this position is 2 to the power 0 1 2 3 4. Okay, 2 to the power 4 is 16. So the IC diagram you have to understand. 4539, there is no 8539, so all about 4539. Now 4008 is basically the adder, 4-bit adder, and if you see the internal structure of this, you can say there will be 4 full adders. So you have this A0 B0, then you have A1 B1, A2 B2, A3, and B3 is here. You will be having the 5 volt and ground. Then C in basically the first carry. What is the first carry? You can check here the circuit diagram. Something that is grounded. Grounded means it should be 0, right? The first full adder, that is A1 B1, or you can say A0 B0, whatever is the LSB 2 bits of A and B, with that some carry will be added, because there is no propagation. That's why we are having this, one. Okay, now you can check it here that how we can generate this one. So for this case, we can, the pin numbers are given, very simple, no need to rush up and all these things. So these are the 4 bits of the A that are connected to this 448 pins. Okay, the initial carry input, that is supposed to be 0. Okay, and these are the 4 sum bits, 10 11 12 13, you can check it here also, 10 11 12 13, and this is the final. So these are the actually the 5 outputs of the sum, including the C out, and the 4 B0 B1 B2 B3 and A0 A1 A2 A3, 4 8 input bits. Okay, Now this is the circuit diagram for this IC 4008. So this 4008, you can see here from the diagram, 4 bits of A, 4 bits of B, and the initial carry Ci, which is connected to 9, I have kept it 0 because initial carry is grounded, because there is no previous stage apart previous to the LSB, right? So when you are adding two numbers A0 and you have the B0, is there any carry? No, definitely. But something, suppose A0 you will be getting, then maybe some carry may be there, right? C1 will, then that will be added with A1 and B1. Okay, you will be getting S1. So like A will be having the 4 bits, but if you think of like this way, this carry, there is no carry here, right? In the first stage there is no carry in this stage. Okay, so scene we are considering it as 0. Okay, so what are the sum values? These are, you should read it from this side. Okay, so this is going to be the MSB, because then you should read from this to this. This is going to be the LSB of the sum. Okay, this is the final carry, so you should read from this way. So 4 bits of A, so you are giving 4 bits of A, you are giving actually the 4 bits of B, and that is the initial carry, that is supposed to be 0. Okay, please remember this, otherwise the circuit will not work. Okay, so let's come to the circuit diagram point of view. Four, 5, 3, 9, B, how many marks are there? Definitely 2 marks are there. If you just scroll down the video, you can just find out. In that IC there are 2 marks. That's why we have used 1 marks for the carry, another marks for sum, right? Or 1 marks for borrow, another marks for difference. So in 4539B, in the question it is given there will be 2 marks. Okay, so you can check it here. You drag it in proper position and you can just debug this one. Okay, so run simulation. So any value you can just have. So if you just go to the sum of the truth table, you can write it here, that if it is suppose 0 A0100 or 00 and B is also 0100, then you can give that one here. Which one is the MSB here? This one. So you can say 0100 is the value of A. I am not given the full thing. Okay, 0100 as per the truth table I have given. Here also for B also I am giving 0100. I just change these values, 0100. The scene value is 0. Okay, and then what is going to be the output? This is the final carry, that is the C out. Then this is S4, S3, S2 and S1. So 0100 is the value that we are getting. Okay, that is if you do it. Okay, so that is the correct one. If you see the theoretical point 0100 and the 2 values are there, you can find it here. What are the thing? You can check it. This row, I am talking about this value. Okay, this value. I have just simulated this value and I have found out this output. Okay, so you can change anything, like you can just check any value, 0 0 1 0 with 0 0 1 0, that is 2 plus 2 is going to be 4, 0 0 1 0 0, it is going to be 4, so it's coming. So if you use the 4008 IC, A is a number that consists of 4 bit. The order you must see, the MSB is this, LSB is this is the MSB LSB, and this is the carry in, that you should put 0 here and you will be getting the outcome. So you can fill up the truth table in the observation table part and you can do any 4 of the given values. Okay, and the last one this is not within your experimental perspective, but I thought of telling you that the BCD to 7 segment, how it looks like. You have seen that is BCD number, you have seen, right? BCD is basically 4 bit value, you have seen. So BCD to 7 segment means you have the 4 bit BCD number and you have the 7 segment display. It's look like this way, A B C D E F G, and you can find out if you give any number, if you give 1 or 2 or 3 up to 9, 0 to 9, any value you can give here and you will be getting that particular display here at the output. Okay, that means you can check here that if you are giving a 0 value, that is the BCD of this will be 0 0 0 0, and you will be getting this display all the 0, and when all the 0 means that is A B C D E F will become 1, right? The G will become 0. So that is happening here, and for any values up to 9 you can find it, the corresponding A B C D whichever is required, that will become 1 and the rest segment will be off. So I have thought of discussing this value. So this IC is basically, that is 4511 IC, and you have used 17 segment. So you can use 0000 as the input combination and you will be getting the output as this. Similarly, if you just so what is the thing, I have used 0000 as the BCD number input. So A B C D, the 4 pins are given here, and for sake of remembering you must remember that the values LT and BI, these the activation point, these two must be 1, and this strobe value STB bar is basically grounded with the 0, that is the A7 segment display. Okay, so this is the thing. For the 0001 you can do it, it will be 1. So this is the way you can. So the MSB is basically D and the LSB is basically A here for this case. So it depends on different IC. For this type of IC your value is like this only. Is there any question from this point? Okay, so any value, if you have 0010 means 2, you will be getting this 2 in this case. So up to 9, 3, 4, 5, 6, up to you can 0011 is basically 3 in BCD you will be getting here. So you can do it. Let's do some practical. So that is the application of 4511 and 7 segment. Okay. Okay, so you can see here what are the inputs I have taken here. That is the logic state and logic probe, and this 4511 is the input along with the 7 seg COM cathode. Okay, this is used for the 7 segment display. So the thing is that LT and BI, these two are the values that we should give power to this, and this STB, the strobe value, is active low here in this case because the symbol is like this, active low signal. So STB bar means this pin will be activated this when the input is going to be 0. Okay, and this is the common cathode. Okay, so this is connected with the ground. So if you just simulate this one, it will be interesting if you do it one by one. These are the pins that you need, that is there in the data sheet, and you can search the data sheet of 4511. It is there in the data sheet. You need to do this one for the activation purpose. Okay, so you can change any value. So you can change 1, or you can change 3, or you can change 7, or you can change to up to 9, because it is BCD. You can do it for 8, or you can do it for up to 9. You can do it. Okay, 1001 is up to 9, but if it is more than 9, that is 1010, it will not glow. So you have understood, right? So 4511 is BCD to 7 segment we can do it, but if it is 10 and above, it is not going to show it. Okay, so for that you may need, you can just do it for your entertainment for ABC, how you are going to. So for this case, for A 8, or you can say for 7, for you can say 6, okay, for you can say 5, all these cases you can find out that it is working. Okay, but remember these 2 points that I have told you, that these things are important, that is you need to provide these 2 conditions. Those are given in the data sheet, so you have to do it likewise. Okay, so this is all about the experiments of the combinational logic part. And lastly, that I want to show you one thing, that I like to thank Shobik, that he told me that this may be some beneficial, this is going to be beneficial for the friends who are actually not having the laptop, and they can use this simulator, that is the logic circuit simulator. That is, you can avail that one in the mobile app, and I will share the YouTube how to do this one, the tutorial point of view, and you can do it in your phone, that you can use this app. You can search here logic circuit simulator pro, if, because in the exam ultimately something you have to show, right? So it's not like that you cannot do anything and we are going to give you marks. It's not going to happen. Okay, so whether the 3 options are there, those who are not here, please tell your friends also. Either they can do it in Proteus, the second option is circuit verse, and those who are not having the laptop, and even they have a laptop there but they are unable to install Proteus, the third option they are having this logic circuit sim. This app is available in the Google, that is the Google Play Store. Thank you, Shovik. I will just tell you that at least you have searched for something which is positive for many of us, and you can do it. So this is the actually the collection you can just put here, and you can, if you just click here, you will see a collection of gates here, including the sequential, that is AND or not, even 3 input gates are available. Okay, along with the flip-flops are there, some multiplexers are there, and you can, I have just simulated a simple circuit. Okay, so you can see the gates are here. If you click here, because from mobile I cannot connect, but I have done a small circuit, and I have showed this one, downloaded this one here. So you can use the connecting this one, you can use the touch this one, the connection, and for different applications are there, so you can do it by yourself. Okay, and it's not very complicated, so you can do it. But this special ICs are not there. Definitely that is another problem. Still, at least some of the experiments you can do it, and the theoretical part of this IC you can read, so that we can give you the questions and you can answer the questions at least from theoretical perspective. It's not like that we will not give the questions, we will be giving you the questions. And because the class is for all, it's not that we are telling like bullshit and you people are just listening, we are not listening. So it's not going to happen. Okay, so please tell your friends to go through the videos, otherwise they will be in real problem. Okay, so thank you for being in the class. Hopefully we will meet in the next class, or hopefully we may not. So if you have any doubt, I will be always available in the WhatsApp. So please note it down, my number. I will be telling you the number. You can just ping me if you have any doubt regarding the practical part of the VL, that is the digital. Okay, so you can note it down, the number. I am just writing it down. Okay, so if you have any doubt, you can just ping me and you can just text me if you require. Okay, so thank you all. Maybe my words are a bit caustic, but I hope you have understood our point of view also. So thank you all. So assignment I will be posting you, but the deadline I will be telling you in the Google Classroom. Okay, please give the attendance that is required at least for the submission of today. And the assignment I have jotted down, but I have not assigned it in the classroom. I will be assigning this one. Okay, so in the classroom I have anyways I will be showing you the assignments. The net is a problem because lots of things are running. Okay, so I will be assigning you the thing. So I have not given any deadline, so by end of the week you must complete all these things. Okay, okay, so thank you all. The PPTs I will be posting like the way I used to post it, and take care. Thank you.